Okay, I think we're live. So today is Wednesday. We're making it Wednesday. So anyway, today is lesson 4.1b. So we're going to continue with square roots. And then what we're going to talk about today, let's real quick review. If I had a square, let's go 3 square roots of, say, 24x to the 7. Let me do a real quick review because there's no warm-ups. What I would do is break down the 24. The 3 is fine. Leave the 3 alone because outside it's not a square root, so leave the 3 there. What I know about 24 is I'm looking for multiples that have perfect squares. So, for example, 4 times 6. 3 and 8 won't do you any good, but square root of 4, square root of 6. X to the 7th is not an even. It has to be an even exponent. So I'm going to take 1 away from it and write as the square root of x to the 6th times the square root of x to the 1. Okay. Now, the reason we reduce square roots is because then we can get it to look much smaller, and then we can do more with it later. Okay. So let's keep going. So the 3 stays out, so we're going to 3. But the square root of 4, I can do. Square root of 4 is 2. Square root of 6, I cannot do anything with it. It's just an ugly decimal. But I can take the x to the 6. I can take half my exponent and make it x3. X by itself, you can't do anything with it. It's just plain old x. So what's left over? A 6 inside the square root and an x. So let's put those together. Square root of 6x. So to finish this up, I'll make it a 6x cubed square root of 6x. Okay. So these two, the original and the answer, are both the same answer, same square root. But this one's much more reduced, and we can do much more with this later on. Okay, now, today, let's talk about this. Okay, so the next rule is this. Okay, I want you to write this down. You cannot have a square root in the denominator. Okay, or the bottom of the fraction. That's the bottom. That's the fancy word for denominator. So as an example, if I have 3 over the square root of 2. So the rule is that you can't have a square root in the bottom or in the denominator. So what we do is we fix the problem with the problem. Write that down. We're going to fix the problem with the problem. What does that mean? Okay, well, fix the problem with the problem. Why don't you write that down? What the heck does that mean? Well, when I take a look at the problem is the square root in the bottom. So the rule is you can't have the square root in the bottom. So that is the problem. So I'm going to multiply top and bottom by the square root of 2 over square root of 2. And I like to use a different color so that you can see in red that this is my fix. Well, how's that going to help? Well, when we multiply 3 times square root of 2, that's a regular number, and that's a square root number. So we can't technically multiply them, but we'll rewrite that as 3 square roots of 2 over, and then the square root of 2 times square root of 2 makes the square root of 4. And then what I'm going to do is take the square root of 4, and I'm going to get an answer of 3 square roots of 2, and then the square root of 4 becomes plain old 2. Now, at this point, don't divide the 2's, because this really is not a 2. The square root of 2, in fact, we'll take a look at that. If I go the square root of 2, that's really just a really bad decimal. So we leave it as the square root of 2. So you cannot divide the square root of 2 over 2. But what we've done is we've gotten rid of the square root. Because remember, you cannot have a square root in the bottom. We don't. These two have the same value, but this follows through. Okay? Now, let's keep going with this. Okay? So let me turn the page for me. So, as another example, okay, we can even do that with variables. So, let's back up. Let's not do the variables. Let's do one like this. Let's do a big square root of 5 over 3. Okay. So when I see something like this, it really can be 2 different square roots. So let's rewrite this as the square root of 5 over the square root of 3. Right? Now you can't have a square root in the denominator. That's the rule. So remember I told you we're going to fix the problem with the problem. So we multiply the square root of 3 over the square root of 3. And again, I like to multiply with a different color because in red it's showing my step to fix it. So I fix the problem with the problem. What's the problem? The square root of 3. So we multiply top and bottom by the square root of 3 over square root of 3. You have to do the same thing, top and bottom, same thing, because that's like multiplying by 1. Anyway, so now I can multiply these two. They're both square roots, so I get the square root of 15 over the square root of 9, right? Square root of 15 over square root of 9. And I know what the square root of 15 is, it's 3. I'm sorry, I know what the square root of 9 is, it's 3. So I get the square root of 15 over 3. Don't divide the 15 to 3 because that's not really a 15. In fact, again, I'll show you the square root of 15. That is a really bad, ugly number. So don't divide those two because that's a regular 3. And this is 3.8729833346, blah, 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 blah. Okay, so that's my answer. Okay, now there are these really strange problems that I want to show you, like this. Next example. If I have, say, 5 over 1 plus the square root of 3. Okay, again, you have a square root in the bottom. But this one's different because of the plus sign. If you multiply by the square root of 3 over square root of 3, I can show this to you. I'll do it real quick, and then we're not going to do it this way. Don't copy this. But if you multiply by the square root of 3 over the square root of 3, the problem is that you'll still, if you distribute, you'll still have a square root of 3 on the bottom. That's not going to work. So if we have a plus or minus on the bottom, we're going to multiply by a thing called the conjugate. That I want you to write down. Conjugate. Right? So we do the problem correctly. So just because of the plus or minus on the bottom, we'll have 5 over 1 plus the square root of 3. I'm going to multiply by the opposite. The conjugate is like the opposite. Alright, so I'm going to multiply by, ready? 1 minus the square root of 3. And on top, I'll do the same thing, 1 minus square root of 3. And again, I do it in red to show the difference in colors. So you do the opposite. So you get rid of the square root at the bottom, I'm going to multiply by the opposite of that. It's called the conjugate. So let's see how that helps, okay? So go ahead and do this, because I know my answer is going to be a fraction. 5 times 1 is 5. And 5 times the square root of 3. Now you got to be careful. That's a regular number. That's a square root number. So we're going to make it simply, because there's an invisible 1 right here, we're going to make it a minus 5 square roots of 3. Okay, you cannot multiply the square roots to the regular number, but I can rewrite them together because I can multiply times that invisible 1 and make it 5 square roots of 3. Now on the bottom, we're going to FOIL. 1 times 1. Okay, 1 times 1 is 1. 1 times the square root of 3, remember there's an invisible 1 here, makes a negative 1 square root of 3. Okay, we're going to multiply the inside. Now there's an invisible 1 here, so 1 times 1 is 1, so I get a positive 1 square root of 3. And then I'm going to get a negative 1 square root of 9, because I'm going to go 3 times 3, because I can multiply these. Negative 1 square root of 9. And here's what's going to happen. I still have square roots on the bottom, but they're going to disappear. Remember, the rule is you can't have a square root on the bottom. So when I do that, these two cancel. Negative 1 square root of 3 and a positive 1 square root of 3. And I know the square root of 9 is plain old 3. So that's going to become a plain old 3. So let's see what we have. 5 minus 5 square roots of 3 on top. Okay? And you can't subtract those because that's a regular number and that's a square root. You can't subtract these. And then on the bottom we'll have a 1 minus 3. See the minus 3? Well, 1 minus 3. See the negative 3 because of the negative right there? So then my answer is 5 minus 5 square roots of 3 on top. Again, you can't subtract those over a negative 2. Okay? Now, what have we done? There's no longer a square root on the bottom. Okay? All right. Turn my page. Now, let's talk about, we've looked at multiplication briefly, and I want to look at one more type of multiplication. Okay? And then we're going to talk about addition. Okay? So real quickly, I briefly showed you a little bit of multiplication, but let's do one with distributive, okay? So an example, if I have 2 square roots of 3 times big parentheses, 3 square roots of 6 plus 3 square roots of 3. Okay, I want to do this. Now, this is actually pretty easy. We're just going to distribute. That times that times that. When we multiply, we'll multiply whole numbers with whole numbers, square root numbers with square roots. We'll multiply whole numbers with whole numbers, and square root numbers with square root numbers. So, I'm going to get 6 square roots of 18. So I multiply these two, 2 square roots of 3 times 3 square roots of 16, I'm going to get 6 square roots of 18. Plus, I'm going to get a 6 square roots of 9, because I'm going to go 2 square roots of 3 times 3 square roots of 3, I'm going to get a 6 square roots of 9. Okay, now I've multiplied. Can I do more? Yes. I can do more because this square root of 18 can be broken down into nice multiples, like 9 times 2. So I'm going to go 6 times the square root of 9 times the square root of 2. Because that is 18, and I will take the square root of 9. Plus, 6 times, well, the square root of 9, that's easy. Square root of 9 is just plain old 3. Almost done. So I get 6, square root of 9 is 3 here. I get 6 times the 3, because square root of 9 is 3, times square root of 2. That can't be done. That's just an ugly decimal number. Square root of 2, again, leave square root of 2 the way it is, because it's really that ugly decimal, so leave it as square root of 2 plus 6 times 3 is 18. Okay, finally, I'm going to multiply these two whole numbers together. 18 square roots of 2 plus 18. That is your answer, because that is the square root of 2. That's not. So you're done. Okay, now let's talk about adding or subtracting, and we'll be done. Let's go back up here and look at this one. I did not add these two because they were different. So if they're the same, we can. Okay, so my first example would be something like this. Let's go 3 square roots of 5 plus a 2 square roots of 7 minus a 6 square roots of 5 plus 10 square roots of 7. Okay, so let's see what we got. Go ahead and write that down. So, they're just like x's and y's. If they're the same, we can combine them. These two are the same. 3 square roots of 5 minus 6 square roots of 5 makes a total of negative 3 square roots of 5. Okay. 2 square roots of 7 plus 10 square roots of 7, these are the same. You can add these and make a 12 square roots of 7. That's it. You can't add these because they're different square roots. Finished. That wasn't so bad. Okay, in the next example, at first it's going to look like you can't add them, but we're going to do a little bit of math and see if we can. So let's take a look at a problem like this. I've got 2 square roots of 18 minus the square root of 8 plus 3 square roots of 12. Okay, when I first look at all three of these, go ahead and write that down. Okay, when I first look at all three of these, they're different. Can't add or subtract them, can't add or subtract them because they're different. But if I reduce them, they might be the same. So let's start. 18, let's see. Let's use 9 times 2 because 9 is a perfect square. Don't use 6 and 3. 9 times 2. So I'm going to rewrite this as 2 square root of 9 times the square root of 2 because 9 times 2 is 18. This 8, there's an invisible 1 in front, right? I'm going to rewrite this as the square root of 4 times the square root of 2. I like the square root of 4 because there is a perfect square root of 4, okay? Plus 3. I'm going to rewrite 12 as square root of 4 times square root of 3. I'm not going to use 6 and 2, but 4 and 3 because 4 has a perfect square root. Okay, now let's see what I have. I can take the square root of 9, I can take the square root of 4, and I can take the square root of this 4. So let's do that. So I'm going to go 2, because it's a regular 2. Leave the whole number alone. Square root of 9 is 3. Took the square root of 9 times square root of 2. Leave the square root of 2 alone. It's an ugly number. Minus 1. Square root of 4 is 2. Let's take the square root of 2. This square root of 2 is just an ugly number. Square root of 2, we have to leave a square root of 2 plus 3 is my whole number. Leave it there. Square root of 4 is 2. And then the square root of 3 is just the square root of 3. It's an ugly number. Leave it alone. Now, what do we got? 2 times 3 is 6. I'm going to do that. 2 times 3 is 6. Square root of 2. 1 times negative 2 is a negative 2. Square root of 2 plus 3 times 2. Multiply the whole numbers. 6 square root of 3. Okay, what do we got left? Let's see. Looks like these two are the same. So I can subtract these two. 6 square root of 2 minus 2 square root of 2 is just going to make a 4 square root of 2. And then the 6 square root of 3 is different. It's different. So we just bring it down. Plus 6 square root of 3. Okay. So, homework. Let's take a look at it. Okay, here's what I want to do today on page, it's in our journal, page 114. So we're going to go to page 114. So we're going to go to page 114. I'd like you to do 1326 all. Okay, and let me get you started on a couple of them. So on 13, for instance, I would go the square root of 15, but then on 500 I'd go the square root of 100 times the square root of 5. Okay, I'd go there. These two you can divide because they're both square roots. So I'd have the square root of 3 from those two, and the square root of 100 is plain old 10. There's not a square root in the bottom, is there? Okay. I'll let you do 14 because square root of 100 is 10. Okay, on 15, I would probably cancel some things before I do anything because they're both square roots. I'd cancel there. I'd cancel there. I'd cancel an x for an x. And I'd start working on the 80. So I'd have a square root of 3. And I can cancel. So I'd have an x inside. Square root of 80, let's see. How about 16 and 5? I think so. Double check on my calculator. 180. How about, wait, hold on. 80 divided by 5 is 16. Yeah, I like 16. So I'm going to go the square root of 16 times square root of 5. And you're going to have to fix the 5. Okay, and I'll let you keep working on that. Okay. Cube roots are a little bit harder, but I'll help you on the cube roots. 8 cube root of 8 times the cube root of 2, and I'll let you work on that. Now, when you get down to 17, you got to multiply by the conjugate. Okay, so that's the opposite. And 18. So I'm going to multiply 17, and you might need to put this on a separate sheet of paper, but I'll multiply top and bottom by negative 3 plus 3 square roots of 3, negative 3 plus 3 square roots of 3, okay? When you get down to 22, you're going to have to add them. So you're going to get your 3. I'm going to break down 8 into the 4 and 2. I'm going to break down the 4 and see if I can add them. On 25, I'm going to distribute. And on 26, I'm going to do a FOIL problem, and we'll see what happens. Okay, good luck. Go ahead and email me or text me if you have any questions. I'd be happy to help, okay? All right, we're off.